Welcome to the deep dive. So you sent over some really interesting stuff about launching an online ebook app. We've got this comparison doc.
Yeah, it lays out two pretty different ways to go about it.
Right. So today, let's really dig into that. We're going to unpack these two deployment approaches you've outlined.
Sounds good. We've got Tome Stack, which seems more conceptual using DigitalOcean and Docker, and then Tomlight Basic, which looks like it's based on an actual setup using Firebase.
Exactly. And what jumps out immediately is just how different the philosophies are. Tome Stack is very much IaaS, right? Infrastructure as a service. You're managing servers with DigitalOcean using Docker.
Very hands-on. Whereas Tomlight Basic goes the PaaS route, platform as a service, maybe even serverless, leaning heavily on Firebase.
Almost opposite ends of the spectrum, you could say.
Pretty much. And, it's crucial to state up front, this isn't about finding the single best way.
No, definitely not.
It's really about understanding the trade-offs. What works for you depends on, well, your needs, your team's comfort level with the tech, what you actually want to manage yourself.
Makes sense. Okay, let's start with Tome Stack then.
Yeah.
The DigitalOcean Docker way. You mentioned ES. What does that really mean for someone setting this up?
Okay, so RS, infrastructure as a service. Think of it like you're renting the basic building blocks. In this case, you get a virtual machine, like a Linux server, looks like Ubuntu here, running on DigitalOcean's hardware.
Right.
But you are responsible for managing basically everything on that machine. The operating system, updates, security, all of it.
So unlike PaaS, where the platform handles more of that background stuff.
Exactly. With PaaS, which we'll see with Firebase later, a lot of that underlying infrastructure management just done for you.
Yeah.
Here, it's your job.
Got it. You're the system admin, essentially.
Yeah.
Okay, so on this VM, what's the front end likely to be for this ebook app in the Tome Stack world?
Well, the doc mentions React, and given it's a conceptual stack, it's probably pointing towards a standard setup. Something like create React app, maybe. It's a common way to get a React front end going.
Okay, straightforward enough. And the back end, the part doing the actual work behind the scenes.
For Tome Stack, it suggests a separate Node.js server. Probably using Express.js. That's a super common framework for building the API, handling logic, talking to the database,
Right. A classic separation front end talks to a backend API. Now, how does this code, the React front end and the Node backend, actually get deployed onto that DigitalOcean server? That's the Docker part.
That's the Docker part, yeah. The key idea here is the Docker container image. You package your application, the Node code, the React build, all the libraries they need, specific versions, and all into this image.
Like a self-contained box.
Exactly. A standardized unit. You build this image, and that's what you actually run on the DigitalOcean VM. It runs inside a container.
Okay. But just running the app isn't enough, is it? You need a web server in front. You need HTTPS for security, maybe a CDN to make things faster.
You're absolutely right. And this is where that high management overhead listed for Tome Stack really kicks in. You need to manually install and configure a web server, like Nginx or maybe Caddy, directly on the Ubuntu VM.
Yeah.
That web server's job is to take incoming web requests and route them to your running Docker container. And critically, you also need to set up SSL certificates for HTTPS.
Which can be fiddly.
It can be. Tools like Let's Encrypt help a lot, and Caddy even automates it, but it's still something you have to set up and manage. And yeah, if you want optimized global delivery for images or CSS, you'd need to configure a separate CDN too.
Right. So the runtime is basically Docker running on Linux. What about the data? Where do the ebooks live? How do users log in? Where's the database?
So the Tome Stack doc labels those as external, which basically means it's up to you. You have the freedom and the responsibility to choose and set these up, meaning you could install, say, a PostgreSQL database directly onto the same VM, but that adds even more to manage. Or, more likely, you'd use a managed database service, maybe one from DigitalOcean or AWS RDS or something. Same for authentication, you'd integrate some external service. And for storing the ebooks, you'd probably use object storage like DigitalOcean Spaces or AWS S3.
So more pieces to connect and manage outside the main app container.
Yep, they're not bundled in.
Okay, this definitely sounds like a few moving parts.
Yeah.
How do you update the app then? If you fix a bug or add a feature, what's the deployment process, the CI/CD, look like?
Yeah, continuous integration, continuous deployment. With this kind of setup, it's usually more involved. A typical flow might be you push code changes, an automated system, maybe Jenkins or GitHub Actions, builds a new Docker image.
Okay.
That new image gets pushed to a container registry like Docker Hub or DigitalOcean's own registry. Then, the tricky part, you need to tell your server to use the new image. This often involves using SSH to connect to the VM.
Remotely logging in.
Right. Then you'd pull the new image down from the registry, and then you'd probably use a tool like Docker Compose to gracefully stop the old application container and start the new one with the updated image.
That sounds like it could involve downtime if not done carefully.
It definitely can. Automating that whole sequence smoothly, without interrupting users, requires careful scripting and setup. It's not trivial.
I can see why the document flags high infrastructure management.
Yeah.
Can you break down what that means day-to-day ongoing?
Sure. It means you're wearing the sysadmin hat. You have to keep that Ubuntu OS patched and updated for security. You need to manage the firewall rules, keep Jinx configured correctly and securely. If you did run your own database on the VM, you're doing backups, updates, tuning.
Wow.
Plus, setting up monitoring like, is the server running? Is the app responding? Collecting logs to figure out what went wrong. And, as we'll get to, scaling. If you need more power, that's on you too.
Okay, it's a significant amount of responsibility, but surely there are reasons people choose this. What are the upsides, the strengths of TomeStack?
Oh, absolutely. The biggest one is full control. We've talked about the responsibility, but the flip side is you have root access. You control everything about the environment. The exact OS version, specific libraries, kernel settings if you need to get really deep, network configuration, total control.
Which is powerful if you have very specific needs.
Exactly. Or if you need to optimize something in a very particular way. It might be overkill for many, but the control is absolute.
Okay, what else?
That control leads to being technology agnostic. You're not locked into the specific managed services of one platform like you might be with PaaS. Want to use PostgreSQL? Fine. MongoDB? Sure. Some niche database. Install it yourself. Need Redis for caching? Go for it. You pick the tools.
Total freedom of choice for your components.
Right. Then there's portability, which is a big promise of Docker. Your app, packaged in that container image, should theoretically run anywhere that Docker runs. Another cloud provider like AWS or Azure, maybe even your own servers on-prem.
So you can move it more easily.
The core application container, yes. The surrounding orchestration and services might need adapting, but the app itself is portable. Helps avoid vendor lock-in.
Makes sense. Any other strengths?
Predictable base costs, maybe. The cost of the virtual machine itself from DigitalOcean is usually a fixed monthly price, which makes basic budgeting simpler.
Although you still have to add costs for data transfer, maybe that managed database storage.
Well, yeah, definitely. It's just the core compute cost that's often flat. And finally, it's a mature ecosystem. Linux VMs, Docker, Node.js, Nginx. These are incredibly well understood technologies.
Tons of documentation, tutorials, Stack Overflow answers.
Exactly. Massive community support. If you hit a problem, someone's almost certainly seen it before.
Okay. So, control, flexibility, portability, known cost, mature tech.
Okay.
But we know the big downside is that management overhead. Let's recap the weaknesses.
Yeah. Number one is definitely that high management overhead. We've covered it, but it's worth stressing. OS updates, security, web server, database admin, potentially. Monitoring, logging. It's a significant time sink or requires dedicated expertise.
For someone perhaps newer to backend and deployment, what part of that do you think is the biggest hurdle? Is it the Linux admin, the Docker part, security?
Ooh, good question. I'd probably say it's the combination. Understanding enough Linux to secure and maintain the server, plus getting your head around Docker concepts, plus figuring out that CI/CD automation, and doing it all securely. That's a steep learning curve.
Yeah, I can see that. What else?
Manual scaling. If your ebook app gets popular overnight, the TomeStack setup doesn't automatically grow. You generally have to intervene.
Oh.
Either you manually resize your DigitalOcean Droplet, their term for a VM, which usually means downtime while it reboots, or for a better approach, you set up multiple VMs behind a load balancer, but you have to configure all the load balancer, how the VMs are added or removed. It's not automatic.
So you need to plan for growth and react manually.
Pretty much. Then, as we discussed, the complex CI/CD. Setting up that robust automated pipeline to build the Docker image, push it, pull it, and deploy it without errors or downtime, it takes effort and expertise.
It sounds powerful once set up, but getting there could be a project in itself.
It really could be. And finally, just the slower initial setup. Before you even deploy your first line of app code, you've got to provision the VM, secure it, install Docker, install Nginx, configure networking. It takes time upfront.
Okay, that gives us a really clear picture of TomeStack. Now let's flip the coin and look at Tom Light Basic, the Firebase approach. You called it PaaS to serverless. How does the hosting model fundamentally change here?
Right, so with PaaS platform as a service and especially leaning into serverless with Firebase, the game changes. Firebase basically manages the underlying infrastructure for you.
Meaning no VMs to worry about.
Exactly. You don't provision servers, you don't patch operating systems, you don't configure web servers in the same way. You deploy your code or your built application artifacts to Firebase, and they handle running it, securing the base infrastructure, and scaling it.
That sounds like a huge difference in terms of what you need to manage. Now, this abstraction, this sort of black box nature, can that actually be a good thing sometimes, even if you lose some control?
Oh, definitely. For smaller teams or solo developers or projects where speed of development is paramount, offloading all that infrastructure work is massive. You can focus purely on building the features of your eBook app, not on being a part-time sysadmin.
Right, focus on the product. Okay, front end for Tomlight Basic use is Next.js 15. How does that compare to the basic Create React app we assumed for Tomstack?
Next.js is more than just a library. It's a full framework built on top of React. It gives you a lot more structure and built-in features for production apps. Version 15 with the app router, React 18, TypeScript. It's geared towards modern, robust web applications.
And importantly, Next.js handles things like server-side rendering, SSR, or static site generation, SSG, really well, right? Which can be good for performance and SEO.
Exactly. It's designed with those production needs in mind.
And the backend. Tomstack had a separate Node Express server. Tomlight Basic sounds different.
Yeah, much more integrated. With Next.js, especially using features like API routes or the newer server actions, you can write your backend logic within the same Next.js project as your front end.
So one code base.
Often, yes. Your ATI endpoint AP books might just be a file in your Next.js pages subdirectory or a server action function when you deploy this to Firebase.
How does that part work? Where does that backend code run?
Firebase is smart about Next.js. When you deploy, Firebase hosting serves the static front-end parts. The backend API routes or server actions typically get deployed automatically as serverless functions, either Google Cloud Functions or Cloud Run instances managed by Firebase.
So Firebase handles the provisioning and execution of those backend bits too.
Precisely. It's a much more unified deployment model.
Okay, so how do you deploy if it's not SShook and pulling Docker images?
It's generally way simpler. You build your Next.js app locally, usually npm run dild. This creates optimized production files. Then you use the Firebase command line interface, the CLI tool.
Just type a command.
Pretty much.
Yeah.
You run Firebase deploy, the CLI talks to Firebase, uploads your build artifacts, configures the hosting, and deploys those serverless functions for the backend parts. Or you can easily set up GitHub Actions to do this automatically whenever you push code.
That does sound significantly less complex than the Tomstack workflow.
It generally is, yeah.
What about the web server, CDN, SSL certificates, things we had to set up manually in Tomstack?
All managed by Firebase hosting. When you deploy, you automatically get a global CDN for your static files, fast loading worldwide, and SSL certificates. Firebase provisions and renews them automatically for your custom domain. HTTPS just works.
Wow. Okay, zero config for that stuff.
Potentially, yes.
And the runtime environment, no Linux VM. So what is it?
For the front end, it's Firebase hosting's CDN infrastructure. For the backend code, those API routes or server actions, it runs inside managed Node.js environments within Cloud Functions or Cloud Run, orchestrated by Firebase. You don't interact with the underlying OS at all.
Okay, now the doc mentions planned integration of Firebase Backbase backend as a service for database auth storage. What's that about?
Right, so this suggests the full vision for Tomlight Basic involves using Firebase's own backend services directly, instead of setting up an external PostgreSQL database.
You'd use Firestore.
Exactly. You'd use Firestore, which is Firebase's NoSQL document database. For user logins, you'd use Firebase Authentication. For storing the eBook files, you'd use Firebase Storage.
And the advantage there?
The advantage is tight integration. These services are designed to work seamlessly together and with Firebase hosting and Cloud Functions. The client SDKs make it really easy to interact with them directly from your Next.js front-end or back-end code. It further reduces the need to manage separate external systems.
So potentially even less setup and integration work.
Potentially, yes. You're buying into the Firebase ecosystem more deeply.
Which probably makes CI/CD even simpler.
It usually does. The Firebase deploy command often handles deploying everything, hosting, functions, even database security rules sometimes. Setting up a basic CI/CD pipeline with GitHub Actions to just run npm install, npm run build, and Firebase deploy is pretty common and relatively straightforward.
So it feels like low infrastructure management is a fair description here. What does that really leave you responsible for?
It really shifts your focus. You're not managing servers or OS updates. You are responsible for configuring your Firebase project correctly, setting up Firestore rules for security, managing Firebase authentication settings, maybe configuring function memory limits, and crucially, understanding Firebase's pricing and monitoring your usage. But the day-to-day keeping the lights on for the servers is gone.
Okay, let's talk strengths for Atomic Basic Firebase then. What are the big wins?
The number one win is clearly reduced management. We've hit this hard, but it's huge. Firebase handles servers, scaling, OS patching, CDN, SSL, freeing you up to focus purely on your application code.
Which should mean faster development.
Absolutely. That's the next strength, faster development and iteration. Because the platform handles so much and the services are integrated, you can often build and deploy features much more quickly, especially with a framework like Next.js that Firebase hosting understands well.
Makes sense. What else?
Automatic scaling. This is a big one for serverless. If your eBook app suddenly gets featured somewhere and traffic spikes, Firebase hosting CDN and the backend cloud functions generally scale automatically to handle the load. You don't usually need to manually intervene.
That's a huge contrast to the manual scaling in Tomstack.
Day and night difference, often. Then there's the generous free tier. Firebase offers a decent amount of usage across hosting, functions, Firestore, etc. for free each month. This makes it really cheap, often completely free, to get started, experiment, and even run small applications.
Lowers the barrier to entry significantly.
Definitely. And finally, that global CDN we mentioned. Getting fast content delivery worldwide without any extra setup is a major plus for user experience.
Okay, so speed, convenience, auto-scaling, low starting cost. Sounds pretty compelling. But there must be downsides, right? What are the weaknesses of the Firebase approach?
There are definitely trade-offs. One is less control, the black box aspect. You don't control the underlying OS or the specific Node.js patch version your functions run on. If you need really fine-grained tuning or access to specific system libraries, you might hit limitations.
And debugging can be harder if the problem is somewhere in that managed infrastructure.
It can be, yeah. You have logs and metrics, but you can't SSH into the functions environment directly, for example.
Could that lack of control become a real blocker? Say, if the eBook app needed some very specific performance tuning later on.
It could. If your needs become extremely specialized and require OS-level tweaks or hardware control that the platform doesn't expose, then yeah, it might become a constraint.
Okay. What's another weakness?
A big one is potential platform lock-in. Because you're using Firebase's specific APIs and services like Firestore, Auth, Cloud Functions, migrating that entire backend to a different cloud provider or self-hosting it later becomes much more difficult than just moving a Docker container.
That's a really important strategic point. You're betting on the Google Cloud Firebase ecosystem.
You really are. And while you lose server management complexity, the complexity is shifted elsewhere. You now need to deeply understand the Firebase platform itself, its various services, Firestore security rules, cloud function configurations, IAM permissions, quotas, which APIs to enable. The document even hints at needing to manage IAM and enable APIs. It's a different kind of complexity.
So you trade managing Linux for managing Firebase specifics.
In a way, yes. Another potential issue is cost at scale. That generous free tier is great, but Firebase services are usage-based. If your app becomes massively popular, the costs for function invocations, Firestore reads writes, data transfer can add up quickly if you haven't optimized or planned for it.
So automatic scaling is great, but it comes with potentially automatic cost increases if you're not careful.
Exactly. Setting billing alerts is pretty crucial. And finally, there's the occasional issue of cold starts with serverless functions.
Yeah, I've heard of that.
If a function hasn't been invoked recently, the platform might need a second or two to spin up a new instance to handle the first request. It makes subsequent requests fast, but that initial delay can sometimes be noticeable for users hitting an infrequent endpoint.
Okay. Less of an issue for busy parts of the app, maybe?
Generally, yes, but something to be aware of.
Right. Wow. Okay, we've really covered a lot of ground comparing Tomstack and Tomlight Basic, and it's crystal clear. Like the doc says, there's no single right answer here. It totally depends.
Absolutely. And for you listening in, since you shared this and you're looking to, get up to speed quickly and see the different angles without getting bogged down, understanding these fundamental trade-offs is key. It lets you make the call.
Yeah, it really boils down to that core choice, doesn't it?
Yeah.
Do you want the maximum control that TomeStack offers, even though it means managing all the infrastructure yourself?
Or do you prefer the reduced management burden of Tomlight Basic, using Firebase, even if it means less direct control and buying into their ecosystem?
Exactly. Hopefully this deep dive has kind of shed light not just on what these options are, but the why behind them and what the implications are for building your app.
Yeah, moving beyond just the names of the technologies to what they actually mean in practice.
So the final thought maybe to leave you with is thinking about your ebook app, your own resources, maybe your team skills, your long-term goals. Which set of these trade-offs feels like a better fit right now? And maybe what new questions does this raise for you about cloud stuff or serverless?
That's the perfect takeaway. Really chew on those trade-offs. And hey, thanks for sharing the comparison, Doc. It was a great starting point for this dive.
Yeah, it really was. Understanding these choices is just super valuable today, whatever you're building.
Couldn't agree more.
And like always, think about the so what. How does understanding IaaS versus PaaS or Docker versus serverless apply beyond just this one project? How does it fit into your broader learning? That's really where the value lies.